Okay, this is going to be a video for the pre-calc final exam. The first part is graphing without a calculator. Okay, so the first thing you always want to do is you want to make a parent graph. Okay, so I'm going to use -2, -1, 0, 1, and 2. Okay, my parent function here is absolute value. So absolute value of -2 is 2, of -1 is 1, 0 is 0, 1 is 1, 2 is 2. Okay, then what I want to normally do is solve the inside. Well, I don't really have anything to do with that because there's nothing on the inside there. Okay, then I want to find the interval, which is 1 divided by the number in front of x, which in this case would be 1, so I would just keep this. Then I want to change the y's by multiplying by -1 and then adding 6. Okay, so that's -2 plus 6 would be 4. There'd be -1 plus 1 would be 5. This would be 6. -1, 5, 2, 4. Okay, so I graph that 0 over 6. Okay, 1 over 5. I'm going to do my best with this. 2 over 4. -1 over 5. -2 over here. So this is what this looks like. Okay, I'm going to make the chart from down here from now on. Okay, so what I have here, okay, all right, I got -2, -1, 0, 1, and 2. Okay, all right, so what I'm going to have with this, okay, this is x squared. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. I solve the inside. Okay, if I solve that, that would be 3, so I'm going to replace that. The interval would be 1 divided by the number in front of x, which is 1. So that's going to be 4, that's going to be 5, that's going to be 2, that's going to be 1. And then what I want to do is I want to multiply by 2 and then subtract 10. Okay? Okay, so multiply by 2 and subtract 10. So that would be 8 minus 10 would be -2. That would be 2 minus 10 would be -8. This would just be -10. Okay, that would be 2, that would be -8. That would be -2. Okay, so I got 1 over -2 down, so somewhere in here. 2 over -8 down, so somewhere in here. 3 over -10 down, so somewhere in there. 4 -8, somewhere in here. Okay, and then 5 -2, somewhere in here. Okay, that's a 5 there. Okay, and so your graph looks like this. Okay, so let me scroll on to the bottom here. Okay, all right, x cubed. Okay, so same idea, -2, -1, 0, 1, and 2. X cubed is the parent function, -2 cubed, -8. -1 cubed is -1. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. If I solve the inside, that would be -1, so I'm going to replace that. I got 1 divided by the number in front of x, which is 1, so I'm going to be an interval of 1, so that's going to be 0, 1, -2, -3. Nothing out there, but I'm just going to add 2, so that's going to be -6, 1, 2, 3, 10. Okay, so -3 over 1, 2, 3, -6 down, somewhere in here. -2 over 1 down, somewhere in there. -1, 2, somewhere here. 0, 3, somewhere here. Okay, and then 1, 10. All right, all the way there. So what I got, something looks like that. Okay, log. Okay, all right. Now what's convenient about log? -2, -1, 0, 1, and 2. Okay, logs don't have these. Okay, what you do have to graph is you have to graph the asymptote first. So in logs, okay, this is going to be the asymptote, which is going to be at, if I solve that, it's going to be at 4. Okay, so I'm going to have an asymptote at x equals 4. Okay, so solving the inside, that's going to be 4. That's the asymptote. Okay, all right. Nothing is on the out. Well, hold on 1 second. We're doing log base 2 to the x. So if I put 1 in there, that could be 0. I put 2 in there. Remember, if you have 2 and 2, that's going to be 1. Same thing if you have 3 and 3, it's going to be 1. Okay? All right. So switch that or solve for that. That's going to replace 0. It's going to be 4. Okay, my interval is going to be 1 still, so that's going to be 5 and 6. okay, I need to add 3 to this, so that would be 3, and this would be 4. So 4 over 0, that's the asymptote. 5 over, 1, 2, 3 up, okay. 6 over, 4 up. So this is what it looks like here, and it just levels off, okay? All right, so if you have a base 3, you would replace that with a 3, okay? All right, that's an exponential one, okay? So what I would do with the exponential graph, okay, -2, -1, 0, 1, and 2, 3 to the x, okay? 3 to the 0 is 1, 3 to the first is 3, 3 to the second is 9, 3 to the -1 is 1/3, 3 to the -2 is 1/9, okay? Now, what I have to do is I have to use my exponent. I have a horizontal asymptote when I have that at -7, okay? All right? Now, there's nothing to solve for in there, so I'm good. I'm just going to have to subtract 7 on the outside, so that's 2, that's -4, that's -6. 1 divided by 3, okay? 1 divided by 3, 0.3, all right? 0.3 minus 7 is -6.7. This is -6.9, okay? So 0 over -6 down would be here. 1 over -4 down would be there. 2 would be here. -1, -6.7 would be somewhere in here. And then -2, -6.9. So this is what this looks like. Okay, all right. For sine, cosine graphs, what you got to do, very similar concept. We're doing -2 pi, -3 pi over 2, negative pi, negative pi over 2, 0, pi over 2, pi, 3 pi over 2, and 2 pi. You're using the parent function of sine, the axis points. At sine, that's going to be 0. That would be, pi over 2 would be 1. Okay, that'd be 0, -1, 0. Negative pi over 2, you go back with the unit circle the other way, so that's -1, 0, 1, and 0. Okay, same deal. We would solve the inside. If I solve that inside over there, that's 4x plus pi equals 0. That's going to be x equals -pi over 4. Okay, let me move that because it's not a great location to put that. Okay, so that's going to be -pi over 4. Now, I would do pi over 2. That's my interval divided by the number attached to x, which is 4, which is pi over 2 times 1/4, which is pi over 8. Okay, so what I want to do is I want to add an eighth. Okay, so -1/4 plus 1/8. If I get a common denominator, that would be -2/8 over an eighth. So -2/8 plus an eighth would be -1/8. -1/8 plus an eighth would be 0. 0 plus an eighth would be an eighth. Eighth plus an eighth would be 2/8 or pi over 4. -2/8 minus an 8 would be -3/8. Okay, -4/8. -5/8. -6/8 or -3/4. Okay, so then what you want to do, okay, with your graph, all right, this is going to get pretty messy, but I'll do my best here. Okay, that's going to go from 1 pi to -1 pi. So what I want to do is put it in half, so pi over 2, okay, and then I want to cut it in fourths, so pi over 4, 3 pi over 4, -pi over 4, -3 pi over 4. Okay, now I forgot to do this. I want to multiply everything by 2 and then add 1, okay? So that's going to be 1, 2 times 1 is 2, plus 1 will be 3, 1, -2, it'd be -1, okay, so 1, 3, 1, -1, and 1. Okay, so I know it's a little messy. I'm really out of room here on this. So -3/4, I'm at 1, and -5/8. Okay, now I got to cut the 8s, so these are going to be my 8s. 1/8, 3, 5, 7, -1, -3, -5, -7. So at -5/8, I'm at 3. Okay, at -1/2, I'm at 1. At -3/8, I'm at negative 1, I know this is really bad, at negative pi over 4, I'm at 1. Okay, at negative pi over 8, I'm at 3. At 0 pi, oops, I'm sorry, at negative 1/8, I'm at 3. At 0, I'm at 1. At 1/8, I'm at negative 1. And then 1/4, I'm at 1. So I think this is what this looks like. Okay, so sorry about that. It's not great. I'm sort of out of board space here. I don't have great board space on this one. Okay, all right. So I'm gonna do my best. I'm gonna try to make this down here, so I have plenty of room. So now when you're doing, let me do the secant one because it's very similar. Okay, when I do secant, the only thing that I would relate this to cosine. Okay, now instead of 0, you put undefined, and obviously 1 is still 1, negative 1 is still negative 1. Okay, so this would be 1. This would be undefined instead of 0. This would be negative 1. This would be undefined instead of 0. This would be 1. This would be undefined instead of 0. This would be negative 1. This would be undefined instead of 0. This would be 1. Okay. All right. Now, if I solve the inside, okay, I got 2x equals 0. That's going to be x equals 0, so that's going to stay. Okay. I would do my interval of 1 over 2 pi divided by 2. That's going to be 1/4 pi. Okay. So there'll be 0. 0 plus a fourth is a fourth. A fourth plus a fourth is 2/4, or pi over 2. All right. Then 2 pi over 2 plus 2/4 plus a fourth is 3/4. 3/4 plus a fourth is 4/4, or 1 pi. Okay, and then subtract that to be negative 1/4. All right, negative 2/4, negative 3/4, and then negative pi. Okay, all right. So what you want to do here? Okay, we're going from negative 1 to 1. Okay. All right, so we want to cut this in half. And then cut it into quarters. 1/4, 3/4, negative 1/4, negative 3/4. Okay, the other thing I got to do with this is I got to multiply everything by 5. So this is 5, this is negative 5, this is 5, this is negative 5, this is 5. Okay, so what I want to do, all right, once again, this is not great board space. At negative 1 pi, I'm up at 5. Okay, at negative 3/4, I'm undefined, so I would make an asymptote through that. At negative pi over 2, I'm at negative 5. At pi over 4, negative pi over 4, I'm undefined. Okay, at 0, I'm at 5. Okay, at 1/4, I'm undefined, so those are just asymptotes. At pi over 2, I'm at negative 5. At 3 pi over 4, I'm undefined. And then pi, I'm at 5. Okay, and I think that we all know that that would go that way. There's an extra asymptote out that way, this way, this way, this way, and this way. Okay, all right, with cotangent, okay, all right, the difference is instead of using pies, I go to fourths. Okay, so what I'm going to do, I'm going to be 0, pi over 4, pi over 2, 3/4, and then 1 pi. And then I go negative pi over 4, negative pi over 2, negative 3/4 pi. I'll make this a little bit longer. Negative 3/4. okay? So I'm using cotangent. So cotangent of 0, that's cosine over sine, just as a reminder, okay? Would be 1 over 0, which would be undefined. At pi over 4, it's 1. At pi over 2 would be 0. But this one would be negative 1. This one would be undefined. Okay, this one would be 1. Okay, this one I go back the other way. That would be negative 1. That would be 0. That would be 1. That would be undefined. Okay, now what I want to do here, okay, is I want to, I got to solve the inside. So if I solve that, that's 2x equals pi over 2. Divide by 2, I get pi over 4. So my new 0 is pi over 4. Okay. Then I want to take the interval, which is pi over 4, and I want to divide that by 2, because that's moving in intervals x, so it's going to be pi over 8. Okay, so 1/4 would be 2/8, so 2/8 plus an eighth would be 3/8. 3/8 plus an eighth would be 4/8, or pi over 2, 5/8, and then 6/8, which is 3/4. Okay, subtract 2/8 minus an eighth would be 1/8. 0, negative 1/8, negative 2/8, or negative pi over 4. Like I said, apologize for the sloppiness. All right, I want to add 1 here, so it's 2, 1, 0, 2, 1, 0. Okay, all right, so what I want to do, here's my graph up here. We'll do this a little bit better. Okay, since I'm dealing with 8s, and I'm going from basically negative 1 to 1, I'm going to get this as wide as I can. Negative 1 to 1, I start with halves. I go to quarters. And then I go to eighths. So 1, 3, 5, 7, negative 1, negative 3, negative 5, negative 7. Okay, all right. So at negative pi over 4, I'm undefined. At negative pi over 8, I'm at 2. At 0, I'm at 1. At pi over 8, I'm at 0. At pi over 4, I'm undefined. At 3/8, I'm at 2. At pi over 2, I'm at 1. At 5 pi over 8, I'm 0. And then 3 pi over 4, I'm undefined. So this graph looks like this going through. Okay, and then let me see if this is actually matching up with the next one. It is not. Okay, all right, so I'm going to pause the video right there. All right, that's the first 8. All right, I'm going to do the next graphs on the next video.